Today we are going to be graphing systems of linear inequalities. And so it's pretty much like what we were doing before, except now we have two inequalities on one coordinate plane. So let's take a look at the first one. And we have a y is less than 2x plus 3. So you just start with the y-intercept. Y is by itself, so here's our y-intercept. So up 3 spaces, we put a dot and then follow the slope. The slope in this case is 2 to 1. So what you're going to end up doing is going up 2 and to the right 1 space. You can also go the other way, down 2, left 1, gets you on that same line. You just draw a bunch of points so that we have some values so we can draw a line between those points. Now, when you look at the inequality sign, there's no line underneath the inequality sign. It's just a greater than symbol, no line here. And so what that means is it's a dashed line. So the points on the line do not give a true answer. It's a boundary between values that are true and values that are not. So you're either going to have true values on one side or the other. Well, once you do that, you move on to the next line, and here there's no x term. When there's no x, that means we have a horizontal line. And so I remember that because you go to the y-intercept. Y is 2. So we're going up 2 spaces. So it can't be a line going vertical because that would be lots of y values. That would be 1, 0, 3, 4. So y is only 2. So that means that no matter what the x value is, y is 2. Now notice I'm drawing a solid line here. You know why it's solid and not dashed? Well, look at the line underneath the inequality sign right there. This tells you that we're going to end up having that solid line. And so from there, what we need to do is figure out the shading for both. So let's go back to our original line here that we drew, this blue line. And look at it. It's a positive y is greater. So greater means more. So we're going to have the y values need to be more than, and then look at the y-intercept. They need to be more than 3. So when we're starting here, looking from this point here, the y values need to be bigger than that number. And so that means they need to go in this direction. So all these values, no matter if you're down here, your y value always needs to be bigger than the number that is on that line. So if the y value here is -1, the y is greater than means that the y values need to be bigger. So that's why you always shade in that direction. We're shading up for that blue line. But we look at the next one, and here it says y is less. So y is less means smaller. Smaller than the number that we have, smaller than 2. And so we're going all the values that are smaller in this direction. Down is the way we'd shade. So you see that there is 4 regions. We've got a region here, here, and down in here. And the only region that works with both is this region right in here. And so that's the region that you shade. It's the one that works with both inequalities. Well, let's take a look at the next one. Here we have y is less than -x plus 3. So we'll start with that positive 3, the y-intercept right here. Go up 3 spaces and put the dot. Then use the slope. The slope is -1. So that tells us that we're going to go down and then to the right. Down and to the right each time. Well, from that point, we can go ahead and go the other direction as well. Up and to the left gets us on that same line. Up and to the left. And then we need to look at the type of line we're going to use. And so here we have y is less. There's no equal sign here, so that means that we're going to have a dashed line. So a dashed line between those points gets us our line, and from there we can draw a arrow at both ends showing that it goes forever in those directions. And I guess right at this point, let's go ahead and figure out which way we shade. Now looking at this, it's a positive y is less. Less means smaller. So here, this is saying that y needs to be smaller than any y value on this line here. So like for instance, this y value here, -2 for that point. That means that the y values need to be smaller than that. Smaller means down. If the y value is way up here at +6, that means that any y value needs to be smaller than that. That's what it's saying here. Y is less, y is smaller. So that's why we end up shading down. Taking a look at the next line, though, we have no y value. So whenever we see that there's no y value at all, that means we're going to end up having a vertical line. And I know that because when we go over to this point at x at 2 right here, you see I can't go horizontal because that would give me lots of different x values. So this is saying that x can only be 2. No matter what the y value is, x is always 2. So that means we have a line that goes vertically. Now I'm drawing dashes because there's no line underneath. That means that the line at 2 is not really a solution. X cannot be 2, but it can be any number bigger than 2. So which way is the bigger values? Well, the bigger values are on this side of the line. And so if you draw an arrow on both sides so you can see the distinct regions, you can figure out which way to shade. So over here, you see we can't shade here because it doesn't agree with either one. Here it doesn't agree with the purple or pink line. Here it agrees with both. And so this is the only region that works with both inequalities. And so that's the region you shade. Well, here's another example. And this time we don't have a y-intercept, or don't see one. And so there's always a number you can add to keep the value the same. If you add 0 years to your age, you're the same age. So we can add 0 to x. We'll get the same value. So that's the y-intercept, is 0, the origin. And then from there follow the slope. The slope is 1. And so that means you're going to go up and then to the right. And you do that a bunch of times, and you have points on that line. We can also go the other way, down to the left. Gets you on that same line. Well, from there, we can go ahead and figure the type of line. It has no line underneath, so we have that dashed line again. And then from there, we can figure the shading. So looking at it, it's a positive y, and it's a positive y is greater. So y needs to be bigger than the value that you're starting at. So no matter what y value you start at, the inequality sign says it wants the y value to be bigger. Bigger would be up in this direction. And so again, bigger, up in this direction. And so we move on to the next one. And this one, we've got to do some work. Y is not by itself. So let's go ahead and move that x term over. I'm going to subtract 2x from both sides. And let's see what we've got left over. We've got a y is less than or equal to negative 2x plus 1. Well, let's go ahead and start with that y-intercept. So the y-intercept is 1, so we're going up one space and then using the slope. The slope is negative 2 to 1. Notice how when you move a term from one side of an inequality sign to another, it just switches signs. So you're just going to go down 2 and left 1. Do that a few times and you got some points. You can also go the other way, up to right 1. Sorry, up to left 1, I should say. Went down 2 and then right 1. Here I'm going up to left 1. And then from there I draw the line. It has the line underneath, so that means solid is the type of line that we're going to end up using. Draw arrows to show that it goes on forever. And reread what it says. It says a y, it's a positive y, is less than. Less means that we want smaller y. So if I'm at this y value, this y is less means that the values are actually should be below that point. Here, the values of y for this point here, it's saying that inequality sign is telling us to go smaller than that point. So the region that works with both is the one that has the arrows agree, and that is this region right in here. And so that's the region that we'd shade. Well, one more example here, and this one, again, this requires some work. We need to get the x term by itself, or the y term by itself, I should say. And so first thing I'm going to do is let's rewrite our problem. 2x minus 3y is greater than 9. So I'm going to go ahead and do an opposite operation. I'm going to move this 2x back to this right-hand side and rewrite what I've got left over. That would be a negative 3y is greater than negative 2x plus 9. So I like to put my x term first. That's called descending order. And that way you can see the slope a little bit easier and also the y-intercept when I get to that point. And so now I am dividing by -3, and that's going to cancel out that -3, that coefficient of y, and I'm left with y. Now, careful here, we divided by a negative. So notice the inequality sign is switching. Here, these two negatives cancel out, make a positive 2/3 x. And here we have a 9 over -3 makes -3. So notice that when you divide by a negative, everything switches. So now it's the inequality sign switched and all the signs as well. So notice I always say positive y when I'm talking about the shading. And we'll see that on this example here. And so -3, start with that y-intercept, go down 3 spaces, put the dot, and then use the slope. 2 to 3, so that means up to right 3, up to right 3. You could also go the other way, down to left 3, and then draw the line. So another dashed line between those points. Now, again, it always works with a positive y, because this is, when we divide by a negative, you end up having to switch that inequality sign. That's why I say always solve for y and always figure that you need a positive y and then read the inequality sign to figure the shading. So here, positive y is less. That means the values, no matter where you're on the line, at that y value, the inequality sign is saying that it wants smaller y's. So from that point, we need smaller y's. From this point here, we need smaller y's. So we are shading below this line. Taking a look at the next line here, it's in slope-intercept form. Right, so all we have to do is go ahead and graph positive 2. That y-intercept, and then -1 is the slope. So down to the right. This is getting us to that line. End up crossing at that point, it looks like. We could also go the other way as well. And this is a solid line. It's a solid line between those points. Well, let's figure out the shading now. Here it says a positive y is less than or equal to. Less means smaller. So smaller would be below the y value. So from this point, you would draw smaller than that would be down. Smaller than this point would be down as well. So where do they agree? Well, it's only one region. It looks like it's that lower region here. So there it is. All the points in this section down here will end up working, but the values in these other sections will not work. And that's graphing systems of linear inequalities. Next part we'll have problems similar to what you see on the review section on page 370.